To crack CAT, you need a lot of practice, and you can practice by taking Cracku's free mock. Just Google search Cracku free CAT mock. Follow the link to get the free mock. We have put in a free mock with the latest pattern and with detailed solutions. Hi friends, welcome to Cracku's video series. In today's video, we'll be taking a look at the top 5 hardest questions from CAT 2017 Slot-2. So we'll basically be taking a look at all those questions which were on the harder side. As you know, in Quant, over the years, the difficulty level has decreased quite a bit. So overall, CAT 2017 Quant was on the easier side. In both Slot 1 as well as Slot 2, there were very few questions that were tricky or difficult to solve as such. So in this video, we'll take a look at the 5 hardest questions and we'll try to identify what knowledge was necessary to solve those questions. So let's get started. Let's take a look at the first question. The first question is, the numbers 1, 2 to 9 are arranged in a 3 into 3 square grid in such a way that each number occurs once and the entries along each column each column, each row and each of the 2 diagonals adds up to the same value. If the top left and the top right entries of the grid are 6 and 2 respectively, then the bottom middle entry is. So what we have been given is that there is a 3 into 3 grid of this sort, and this is 6 and this is 2, and the sum along each of the rows, each of the columns and each of the diagonals, 2 diagonals, so this number and this number, all of these 5, 6, 7, 8 numbers are equal. Now if all the 3 rows are equal, then each of them should be 1/3 of the total possible sum of numbers from 1 to 9. So the sum of numbers from 1 to 9, as we know, is 45. So each of these row totals should be 15. Similarly, each of these column totals should also be 15. The diagonal totals should also be 15 then. So this is how we get this is how we get this as such. So now that we have this information, let's see what would be the possible configuration of this grid. So we have been told that the value along each column, each row and each of the 2 diagonals adds up to the same value. So this value is 15. So we have already placed 6 and 2, so that is 8. So 15 minus 8 is 7. So this missing value should be 7. Now what we have remaining is 2 is done, so I will remove 2, 3, 4, 5, 6, 7, 8, 9. So 6 is done, 7 is done and 2 is done. Now we have 1, 3, 4, 5, 8 and 9. Now let's consider the case of 9. If we put 9 in this row, in this column as such, the first column, the sum would be 15 already with 6 and 9. Then there would be no value that can take the third cell as such. So 9 cannot be in this column. Similarly, if 9 is in this column, the sum would be 16, which would exceed this 15 value as such. So 9 cannot be in this column either. So the 9 has to be in this column. Now we know that the sum along the diagonal is also 15. So if 9 is in this place, in the bottom row in the third column, then this sum alone would be 15 and no value can take this middle cell as such. So the 9 cannot be here, therefore the 9 has to be here. Now this column total is 15, this is 11, so this must be 4. So we have placed 4 and 9 also. Now let's consider 8. Now if we place 8 in this column, that sum alone would be 15, and then we can't place anything in the third cell in the same column. So 8 can't be in this column, 8 has to be in this column as such. Now 8 can be, if 8 is over here, the column row sum of this row would be more than 17 as such. So 8 cannot be in this row, so 8 has to be in this row. Now now that we know that this sum along the diagonal is equal to the sums along the rows and columns. Since this is 6 and 4, this must be 5. If this is 5 and as we see this is 13 plus 2, 15. So the condition is satisfied. We have placed most of the elements now. Now just considering the row total here is 15, so this must be 3, and the row total here is 15, so this must be 1. So we have placed all the elements from 1 to 9. Therefore, we are asked what is the bottom middle entry. The bottom middle entry is 3. Therefore, the answer to this question is 3. So as you could see, this did not require any knowledge as such. This was more of a logical reasoning question than a quant question as such. The only thing that you needed to calculate was that if you're given that the row totals, column totals and diagonal totals are equal, the row totals can be 1/3 of the sum of the 1 to n as numbers as such. So you just needed to know how to sum up 1 to 9 quickly, and 1/3 of that you would get the row totals and column totals, and then just by using simple logical reasoning you could solve the remaining question as such. So as you could see, this did not require any prior knowledge of any formula as such. So this was a pretty easy question for you to solve had you not had any other experience with any other formulas, or you have not prepared. Even then you would have been able to solve this question. Now let's take a look at the next question. Consider 3 mixtures, the first having water and liquid A in the ratio 1:2, the second having water and liquid B in the ratio 1:3, and the third having water and liquid C in the ratio 1:4. These 3 mixtures of A, B and C respectively are further mixed in the proportion 4:3:2. Then the resulting mixture has, the options has the same amount of water and liquid B, the same amount of liquids B and C, the more water than liquid C, more water than liquid A. So we have been given a ratio in which these have been mixed, and these ratios in turn are split up in ways 1:2, and 3 is split up as 1:3, 2 is split up as 1:4. So the way we can do this easily is that we multiply each of these, so this is essentially 4 by 3, and 4:4 is to 2. Let's say the factor is k. Now the factor A means that they are mixed as 4k units, 3k units, 2k units. Now you should assume k in such a way that we can split 4k into 1:2. So k has to be a multiple of 1 plus 2, that is 3. Also 3k has to be split as 1:3. So k has to be multiple of 4. So 3k has to be a multiple of 4. So k has to be a multiple of 4. 2k has to be split in the ratio 1:4. So k has to be multiple of 5. So let's assume a value of k that is 12 into 5, that is 60. So let's assume that k, the common factor, is a multiple of 60, so that we can easily calculate how many units of each are there in the final mixture. So if k is 60, that means that 240 units of the first mixture, 180 units of the second mixture, and 120 units of the third mixture are mixed together. Now the first mixture has water and liquid A in the ratio 1:2. So this means water is 1/3 of 240, that is 80 units, and 160 units is liquid A. So this is water, this is liquid A. In the second mixture, the ratio of water to liquid B is 1:3. So this is 1/4 of 185 is 45. So this is water, and 135 is liquid B. And in the third mixture, we have water and liquid C in the ratio 1:4. So 1/5 is 24 units is water, and 4/5 is that is 96 is liquid C. Therefore, if we consider all of these units mixed together, water will be 80 plus 45, that is 125, plus 24, that is 149 units. A will be in 160 units, and B will be 135 units, and C will be 96 units. So if in 540 units of the mixture, that is the resulting mixture, this is the ratio of each of the elements. So now let's consider what the options are. The same amount, there is the resulting mixture has the same amount of water and liquid B. That is clearly not true. This is 149, this is 135. So this is wrong. The same amount of liquids B and C. Again, this is incorrect. B is 135, C is 96. So option B is also wrong. More water than liquid C. So yeah, this is 149, this is 96. So this is true. More water than liquid A. No, this is 149, this is 160. So the last option is also not true. Therefore, the right option is option C. So as you could see, since we had to use the concept of mixtures and allegations, this essentially resulted, like all you had to do is consider how to represent the overall resulting mixture so that you can easily distribute in one order down into the subparts of water and the liquid. So once you could find out the multiplying factor that was convenient for representation, it was then very easy to find how much of the resulting mixture had water, how much of it was liquid A, how much of it was liquid B, etc. So what was important here was first finding out how exactly to represent the resulting mixture. Once you had that multiplying factor, it became pretty easy. Now let's take a look at the third most difficult question that came in CAT 2017 second slot. This is a question from number systems. So let's take a look at the question. How many different pairs A comma B of positive integers are there such that A is greater than or equal to B and 1 by A plus 1 by B is equal to 1 by 9. So let's start with the equation first. We have 1 by A plus 1 by B is equal to 1 by 9. So we can write this equation as A plus B by AB is equal to 1 by 9, or AB is equal to 9 times A plus B. We can take this term on the LHS, so I can write this as AB minus 9 times A plus B is equal to 0. Now I've been given some extra information. I've been told that A and B are positive integers and A is greater than or equal to B. Now if these are positive integers, I can express them, if I can find a way in which I can express them as a multiplication of two numbers, then I can factorize the constant that I get on the RHS and then find pairs of A and B that satisfies those I can factorize the constant on the RHS and find pairs A and B that satisfy that kind of a relationship. So I basically have to change this equation into an equation such that x minus A into x minus B is equal to some constant. So if I can change this equation to this format, then I can write down all the factors of k, and then I can say that if these are all the factors of k, that means x minus A is equal to this factor and x minus B is equal to this factor. Also, since we have the relationship between A and B, for each factor of k, I will get one pair A and B. So that is my end goal. So let's see how I can do, how I can change this equation to this equation. So I can write this as AB minus 9 times A plus B is equal to 0, or I can write this as AB minus 9A minus 9B. I'll add a constant value k to both LHS and RHS. Now I can write this as A times B minus 9. Now I should be able to get the same factor out of the second part also. So my k should be such that if I take minus 9 in common, I get B minus 9 in over here. So this should be essentially minus 9 into minus 9. Therefore k should be 81. So I'll write plus 81 on both LHS and RHS. So by taking minus 9 in common, I say minus 9 B minus 9 is equal to 81. So I can write this equation as A minus 9 times B minus 9 is equal to 81. Now as I said, I've gotten it in the required form. Now I can write factor is 81 and then say for each factor of 81, A will take a particular value and B will take a particular value. Now the product of these two numbers is positive. So two cases exist, that is, first case is both A minus 9 is greater than 0 and B minus 9 is greater than 0, or the second case is A minus 9 is less than 0 and B minus 9 is less than 0. Now let's first take the following case where A minus 9 is greater than 0 and B minus 9 is greater than 0. If that is the case, then I can say that this is the multiplication of two factors that gives me 81. So what are all the factors of 81? That is 1 into 81, 3 into 27 and 9 into 9. Since it is A minus 9 and B minus 9 and A is greater than or equal to B, that means A will be the bigger factor of the two. So all of these values A will take and correspondingly B will take these values. Therefore, the values of the pairs A comma B such that A minus 9 into B minus 9 is equal to 81 is, so A minus 9 is 9, A minus 9 is 9 and B minus 9 is 9. So A is equal to 18 and B is equal to 18. A minus 9 is equal to 27, so A is equal to 36, and B minus 9 is equal to 3, so B is equal to 12. A minus 9 is equal to 81, so A is equal to 81 plus 9, that is 90. B minus 9 is equal to 1, so B is equal to 10. I hope you understood why I chose the smaller number as B. It's been given that A is greater than or equal to B, and since A and B are positive integers, therefore A minus 9 should be greater than B minus 9. Therefore, A minus 9 will take the bigger factor and B minus 9 will be the smaller factor. By assuming that, you get these three pairs, that is 18, 18, 36, 12 and 90, 10. So, in this case where both are positive, this is case 1, I get 3 pairs. Now, let's consider the case 2 where both are negative. Now, this means that A is less than 9 and B is less than 9. And both are positive integers. So, this is greater than 0 and this is greater than 0. There are no two values A and B, positive integers, which are less than 9, such that their product will be equal to 81. So, there is no case which satisfies this given equation. So, clearly, this value like A minus 9, if A is in this range, A minus 9 will actually be in a range again. It will be in minus, if it is the, it will be in the range minus 9, A minus 9 to 0. Similarly, B minus 9 will also be in this range, B minus 9 to 0. Their product will never be equal to 81. So, given this fact that this will be in this range and if the product will not be equal to 81, this yields 0 cases. Therefore, the total number of cases are these 3 cases. So, there are 3 different pairs that of positive integers such that A is greater than or equal to B and 1 by A plus 1 by B is equal to 1 by 9. So, the answer to this question is 3. So, let's move on to the fourth problem. Let f of x be equal to 2x minus 5 and g of x be 7 minus 2x. Then f of x plus g of x, the modulus of whole of that is equal to modulus of f of x plus modulus of g of x if and only if, and 4 options are given. So, this is a question on functions. Generally, you can expect 2 questions from functions in CAT and they tended to be on the tougher side. So, let's take a look at this question as such. So, we are given like an equation with modulus in it. So, essentially, when you have modulus of any term as such, you have to split up the cases where something is valid. Now, in this case, we will consider the 2 cases where f of x is greater than or equal to 0 and g of x is greater than or equal to 0. Let this be case 1. When this is true, then f of x plus g of x, the whole of modulus of that will be equal to modulus of f of x plus modulus of g of x, because in all of these cases, all of these values will be greater than or equal to 0. So, in this case, this will be equal to true. Now, suppose f of x is greater than 0 and g of x is less than 0. If f of x is greater than 0 and g of x is less than 0, in that case, f of x plus g of x will be different. In this case, if g of x is less than 0, then the negative amount will be invalidated by the modulus. So, this will essentially become f of x minus g of x and this side will be unaffected. Now, suppose f of x is less than 0 and g of x is greater than 0. In that case, we get minus f of x plus g of x. So, even in this case, this is not valid. And the last case is when both are less than 0. When both are less than 0, this will be minus f of x minus g of x. The minus sign will get cancelled and this will be minus f of x minus g of x. So, even in this case, the second case, when both are less than 0, even in that case, less than or equal to 0, even in that case, both of this inequality will hold. The only time they will not, this expression will not, this equation will not be true is when one of them is positive and the other one is negative. Because when one of them is positive and the other one negative, then this expression g of plus g of x will not be carried over here, where this would then instead be replaced by minus of g of x, or we will have minus f of x plus g of x. So, because of that, this expression will hold only when both have the same signs. Either both are positive or both are negative. Now, let us consider the first case where both are positive. Now, if both are positive, then we can say that f of x is 2x minus 5 is greater than or equal to 0 and 7 minus 2x is greater than or equal to 0. So x must be greater than or equal to 5 by 2 and x must be less than or equal to 7 by 2. So x must be essentially between 5 by 2 to 7 by 2. So this is the first region. Now f of x is less than 0 and g of x is less than 0. Then 2x minus 5 is less than equal to 0 and 7 minus 2x is less than or equal to 0. So x is less than or equal to 5 by 2 or x is greater than or equal to 7 by 2. But this can't happen simultaneously. X can't be less than 5 by 2 at the same time be greater than 7 by 2. So this yields no region. So the only region is when x is between the range 5 by 2 to 7 by 2 and this is less than or equal to sign. Therefore the right answer is option D. There is another alternative way in which you could have solved this question without having to calculate all of this. That is by looking at the options directly. So how do you do that? So you are asked when is this true? So you can just consider the different cases and substitute values of x from that particular regions. Now suppose if I assume x is 0. So x is 0 would be valid according to options B and C. If x is 0, then f of x is minus 5 and g of x is 7. In that case, for when x is equal to f of 0 is minus 5 and g of 0 is 7. So in this case it is minus 5 plus 7, so this value will be equal to 2 and this value will be equal to 5 plus 7, so this will be 12. So f of 0 x equal to 0 definitely does not satisfy this expression. So any range which contains 0 will not be correct. So we can directly eliminate options B and C. Now between A and B, if you look at the options, both are identical ranges except instead of less than sign you have less than equal to sign. So to choose between A and D, you just have to see whether x equal to 5 by 2 actually satisfies the equation. So if x is equal to 5 by 2, f of 5 by 2, in this case it is 0 and g of 5 by 2 would be 7 minus 2 into 5 by 2, that would be 2. So f of this value would be f of x plus g of x. If you just add these two together, you see that you always get 2. So this would be 2 and the right hand side would be sum of f of modulus of f of 5 by 2 and modulus of g of 5 by 2. This again also would be 2. So f of x equal to 5 by 2 satisfies the given equation. Therefore the sign should be greater than or equal to 5 by 2. Therefore the answer should be D. So as you could see, without actually solving the entire thing, we could also pick out the right range as such. So in conditions like this, whenever you are given a range in the options as such, pick a convenient number, check whether that number solves the given equation. If it doesn't, you can directly eliminate that option and then you can be left with a lesser number of options where you can then check again which option is valid. So that is an easier way to solve questions like this. So this is how you solve questions where you have to find the possible domain or range in a question involving functions. So now let's go on to the last question. How many 4-digit numbers which are divisible by 6 can be formed using the digits 0, 2, 3, 4, 6 such that no digit is used more than once and 0 does not occur in the leftmost position? So we have to find how many numbers are divisible by 6. So for a number to be divisible by 6, the sum has to be, sum should be divisible by 3 and the last digit should be even. So last digit should be even. So that should be either 0 of the given numbers, it should be 0, 2, 4 and 6. So let's first start by putting the last digit. If the last digit, so there are 4 different cases. First is last digit is 0. Case 1. Case 2 is last digit is 2. Case 3 is last digit is 4. And case 4 is last digit is 6. So these are the 4 possible cases for the number to be divisible by 6. It has to be an even number first. So These are the 4 cases. Now let's try to see how many of them are 4-digit numbers such that the sum of those digits is also divisible by 3. So we have the last digit as 0. So the remaining 3 digits can be, so if we consider the digits that are left, if the last digit is 0, this is 1, 2, 3, the remaining digits are 2, 3, 4 and 6. So if we take 2, 3 and 4, the sum is divisible by 3. So the digits can be 2, 3, 4. This will lead to 3 factorial cases. If we drop in this case we dropped 6. Now suppose we drop 4. If we drop 4, the digits are 2, 3 and 6. The sum will not be divisible by 3. So it can't be 2, 4, 6, 2, 3, 6. Now suppose we drop 3. So the numbers are 2, 4 and 6. So 2, 4, 6, 0, the sum is divisible by 3. The sum is 12. So the sum is divisible by 3. So the digits can be 2, 4 and 6. Again, this will lead to 3 factorial numbers. Then the last, this is dropping 2. So the numbers will be 3, 4, 6 and 0. 3, 4, 6 and 0, the sum is 7 plus 6, 13. So that is not divisible by 0. So that does not lead us to a favorable case. So the number, these 3 remaining digits can be either 2, 3, 4 or 2, 4, 6. Each of these numbers 2, 3, 4 can be arranged in 3 factorial ways, and these numbers 2, 4, 6 can also be arranged in 3 factorial ways. So when the last digit is 0, we'll have 2 into 3 factorial cases. Now let's consider the case where the last digit is 2. So we have the last digit 2 here. The remaining digits are 0, 3, 4 and 6. Now suppose we consider the last 4 digits as 3, 4 and 6. If the digits are 3, 4 and 6, then the sum is 7 plus 13 plus 2, 15. So the digits can be 3, 4 and 6. Now first we drop 0. Now suppose we drop 3. The remaining digits will be 0, 4 and 6. Now 0, 4 and 6, the sum will be 12. So the sum is divisible by 3. So the remaining 3 digits can be 0, 4 and 6. Now suppose we drop 4. Then the digits will be 0, 3, 6 and 2. The sum in this case is 11. So it is not divisible by 3. So the remaining 3 digits cannot be 0, 3, 6. Now suppose we drop 6. The remaining digits would be 0, 3, 4. In this case that is 3 plus 4 plus 9, that is 9. So it is divisible by 3. So the remaining 3 digits can be 0, 3, 4. So 3, 4 and 6, if these are the 3 digits, they can be arranged among themselves in 3 factorial ways. If it is 0, 4 and 6, the first digit can be chosen in 2 ways. It can be either 4 or 6, and then the remaining 2 digits can be arranged among themselves in 2 factorial ways. So that is 2 into 2 factorial. Similarly, the first digit, if the digits are 0, 3, 4, the first digits can be either 3 or 4. That is, it can be chosen in 2 ways, and the remaining digits can be arranged among themselves in 2 factorial ways. So we get this value as 3 factorial plus 2 into 2 factorial plus 2 into 2 factorial, that is 4 into 2 factorial. Now let's consider the case where the last digit is 4. So these are the 4 digits. This is 4. So the remaining digits are 0, 2, 3 and 6. Suppose the digits are 0, 2, 3, then the sum is 5 plus 9. So the digits can be 0, 2, 3. Now suppose we drop, in this case we drop 6. Suppose we drop 3. The digits would be 0, 2, 6 and 4. So the sum is 12. So the remaining digits can be 0, 2, 6. Now suppose we drop 2. So the digits will be 0, 3, 6 and 4. The sum is 13. So that is not possible. Now suppose we drop 0. The digits would be 2, 3, 4 and 6. The sum in that case would be 15. So that is possible. So we have 2, 3, 6. So 2, 3, 6, if these 3 digits are 2, 3, 6, they can be arranged among themselves in 3 factorial ways. If these are 0, 2, 6, they can be arranged among themselves in 2 into 2 factorial ways. Similarly, if they are 0, 2, 3, again into 2 into 2 factorial ways. Suppose the last digit is 6. So we get the remaining digits as 0, 2, 3 and 4. In this case, let's consider one by one. If we drop 0, the remaining digits are 234 and that satisfies the given condition. If we drop 0, it is 3, 4 and 6, 0, 3, 4, 6. The sum would be 13, that is not divisible by 3, so that is not possible. Suppose if we drop 3, it is 0, 2, 4, 6, so 0 to 4 is possible. Now suppose we drop 4, that is 0, 2, 3 plus 6, that is sum is 11, so even that is not possible. So in this case, if it is 3, 2, 3, 4, these 3 digits can be arranged among themselves in 3 factorial ways. If it is 0, 2, 4, the first digit can be taken in 2 ways and the remaining digits can be arranged among themselves in 2 factorial ways. Therefore, let's count the number of ways we have gotten. This is 2 into 3 factorial plus 3 factorial plus 4 into 2 factorial plus this is 2 into 2 factorial plus 2 into 2 factorial plus 3 factorial. So I got another 3 factorial plus 4 into 2 factorial plus this is 2 into 2 factorial plus 3 factorial. So 2 into 2 factorial. So I get a total of 2, 3, 4, 5. 5 into 3 factorial plus I have 4, 8 and 2, that is 10 into 2 factorial. So 2 factorial is nothing but 2 and 3 factorial is 6. So 6 into 5 is 30 plus 20. So the total number of ways is 50 ways. So the total number of 4 digit numbers that can be formed such that they are divisible by 6 is 50 numbers. So this is how we answer question. This, as you could see, this required you some knowledge of permutation and combination, and it basically required you to use enumeration. You could have done it in a shorter way, but I always recommend having mutually exclusive exhaustive cases like the last digit is 0, last digit is 2, last digit is 4 and last digit is 6, because each of these cases is exclusive case. And then if you count it, you won't be double counting and you won't skip counting. So because of that, it becomes very easy for you to not make a mistake if you have clearly defined mutually exclusive, collectively exhaustive cases like this. So as you could see, this required you some basic knowledge of PNC as such. So these are how we solve questions on different questions that came in CAT 2017 that were on the tougher side. As you could see, they required basic knowledge of number systems, very basic knowledge of PNC. There weren't many hard or conceptually difficult questions as such. They just required you to reason out a little bit. So as you could see, this required very few fundamental knowledge as such, very few formulas to remember. All you had to do was remember some basic formulae and consider all the cases separately, have some patience while solving this, and many of them required logical thinking as such. So as you can see, CAT requires some preparation, but the focus is not on formulas, it is more on thinking. So now that you know how to solve difficult questions from Quant, please click the subscribe icon to see more videos of this sort. We'll be putting out a lot of videos about how to prepare for CAT, how to solve difficult CAT questions from the quantitative aptitude section, from reading comprehension, from DILR, etc. So please subscribe to our channel to keep getting more updates about CAT. Also, please check out the description box. We give out a lot of stuff for free, from free mock CATs to free topic tests as such. So please check out the description box to see what all free content is available for CAT from Cracku.in. Thank you for tuning in.